another couple new concepts, I guess, or review concepts, depending on what you know. Composition of functions, one-to-one functions, inverse functions, and then we'll talk about inverse trig functions as well. Some of you I know are taking Math 12 concurrently, so certainly the trig functions might be new to you, unless you've taken that course before. Composition of functions, just to go along with the idea of a function in general. The word composite or compositions, if you talk about I don't know where you might have heard that word before, a composite function, a composite hockey stick or something that's made out of that kind of material. It's two materials or more than two materials put together, and that's where the strength comes from. Like fiberglass, you could call it a composite material. It's got glass, but it's also got little fibers in it, and those two together, the glass makes it really hard, and the fibers make it flexible. So it's got the two together. If it was just glass, you could snap it. If it was just the fibers, you could bend it and it wouldn't have any strength. Composite means putting two things together, or more than two things together. So a composite function is one that's made up of two other functions. On your calculator, you don't have to have your calculator, but it might help to think of it this way. On your calculator, let's say you were, all of these buttons on here, like square root, that's a function. Square root of 9, these sorts of things. If you take square root and put in some number, or if you graph that, right? If we graph square root of, I shouldn't have erased what was just there. Square root of x, that's one function. We can put in here, what else are we going to put here? Sine x. Okay, there's another function. You could put the two of those together and make a composition of that. Right? If you have two different functions, the composition of that would be you could have square root of sine of x. Okay, so you're not multiplying them. You're applying them in sequence to a value. If you put an x value in here and get a y value, and then you take that y value, actually I got to go the other way here because sine's on the inside here. If I put an x value in here, get a value for that, and then put that value in this function. If you apply the two functions in sequence, and I wish I hadn't have picked sine now, let's pick something simpler like x plus 2. Oops. Let's start again here. Let's do some that we can work with nice and easily here. Let's do 5x is the first function, and the other function is x plus 2. Okay? First thing in the morning, that's the kind of arithmetic we want to work with here, right? Okay, so y1 is 5x. y2 is x plus 2. Or you can call it f of x and g of x or whatever. If we're writing it, we should probably use that kind of notation. If you put those together now, again, think of a function as a machine here, right? If one of the functions takes a number and multiplies it by 5, and the other function takes a number and adds 2, think about what happens as you put numbers in here. If you put a number in there, okay, let's make a x, and then this one's going to be called f of x. What values do we have there? 0, 1, 2, 3 is probably good enough. If you put your x values in there, what do you get? 0. Put a 1 in there, you get 5. You put a 2 in there, you get 10, 15. If this one's g of x, you put a value in and you get 2 more, right? 0, you get 2. 1, you get 3. 2, you get 4. 3, you get 5. You can combine those two functions together. If you applied both of those functions, so this function here is putting a number in, getting a number out. This is putting a number in, getting that number out. If you combine them together now, so if you put a number into if you put a number like 0 or 1 or 2 or 3 into f of x, and then you put it into g of x, what do you get? Each of those numbers, what do you get? If you put a 0 in, so you put a 0 in, you apply this function, f of x, so it means multiply by 5, right? So 0 becomes a 5, and then what happens? Becomes a... Sorry, what? Yeah, 0 becomes 0. Thank you very much. I'm awake here. 0 becomes 0 because we're multiplying by 5, right? Multiply by 5, this function is 5x. So you take a 0, it becomes a 0, stays a 0, and then you add that, that's 2. If you put a 1 in here, you get 5, and that becomes a 7 here. If you apply both functions in sequence here, if you're first applying f of x, you take an x, right? You start with the x. Probably I should think of writing it like this. Here's the x, and you apply that function. And then you take whatever the result is there, and you apply this function. That is g of f of x. If you're saying it with words, g of f of x. These ideas are written there, but